Hi everyone, this is your math guru. In this video, I'm going to show you how to apply various factorization method in solving the following. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. We have to factorize the following fully. The first part of the question says 4x squared minus 36. When you have two terms, the first thing that comes to mind is there a common factor? If you go through that, then you can move to the other types of factorization. I'm going to start with the common factor, and I can see that there's a common factor of 4. So if I factor out 4, I'm left with x squared minus 36 divided by 4, that's 9. Now, because we've been told to factorize fully, I need to double check and see that I can further factorize what I have. But if you look at what I have in the bracket, x squared minus 9, that's two terms separated by a minus, and each of the term is a perfect square. So I'm going to apply the difference of two squares that states that if I have a squared minus b squared, a and b perfect squares, that will be a plus b, a minus b. So therefore, if I rewrite what I have in the bracket, for better understanding, that's x squared minus 3 squared. My a in this case is x and my b is 3. So therefore, I'm going to have, don't forget to bring down your 4, that will be x plus 3, x minus 3. I've been able to factorize fully. In the second example, I have 16x cubed plus y cubed over 4. Note that I'm always going to start with a common factor. If there's no common factor, then I move to other forms of factorization. In this example, I can see I have a common factor of 1 over 4. So if I factor out 1 over 4, as shown, I'm left with 64x cubed. I'm going to explain that shortly, plus y cubed. Note that 1 over 4 times 64 will give me 16. Always note that when you factor out a common factor, if I fall back or expand, I must be able to get my original expression. That's 16x squared or x cubed plus y cubed over 4. The next step, because I'm going to factorize fully, I need to check the content of my bracket to see if I still need to further factorize. I have 64x cubed plus y cubed. That is looking like difference or sum of two cubes. So therefore, if I rewrite the content of my bracket, I'm going to have the cube or the cube root of 64, that's 4. So if I change that to 4x all cube plus y cube. I'll change that into a square bracket. Now, using the sum of two cubes, that states that if I have x cubed plus y cubed expanding, that's going to give me x plus y multiplying x squared minus xy plus y squared. In this case, the content of my bracket, which is 4x, will be my x, and then y remains y. So using that code for expanding, I still have my 1 over 4. And the first bracket is x plus y, which will be 4x plus y as it is. And then the second bracket will be x squared. That's going to be the whole of 4x all squared, which will be 16x squared. So I'm going to change that to 16x squared minus, then I have xy. Note that xy will be my 4x times y, which is 4xy, then plus y squared. As shown, I've been able to factorize fully by applying my common factor and sum of two cubes. The next question, 3.3 3, I have 6 in bracket, m minus n, close bracket, a squared, minus 5 in bracket, n minus m, close bracket, a, then I have minus n plus m. We have a lot of terms here, so the first check, like I said, is to see if there's a common factor. This is looking like a grouping. I'm going to use the factorization by grouping. I have a common factor, even though the signs are different. I can see there's a m minus n. However, in the second term, it's n minus m, meaning the sign changes. And in the last term, I have that as minus n plus m. I'm going to figure a way of making sure that the factors are exactly the same with the sign, meaning I have a positive m and I have a negative n. So if I rewrite what I have 6m minus n a squared. Okay, I'm going to bring my a squared to the front beside my 6. It's still the same, 6a squared. Then I have m minus n. In the second bracket, in order to make my n minus m equals m minus n, I'm going to factor out -1. So that means my sign will change to a +5. I'm going to bring my a to the front, and then this now becomes m minus n. And in order to make my last term the same as m minus n, I will factor out a +1, and then I swap my terms m minus n. Note that minus n plus m is the same as m minus n. Therefore, if you look at what I have, I've been able to rewrite my expression such that I have a common term to each of the terms, or a common factor. So therefore, if I take out m minus n, which is the common factor, I'm left with 6a squared plus 5a plus 1. There's an invisible one here, as shown. So that will be +1. I'm going to double check and see if I can still factor. Remember, it says factorize fully. Now, because the coefficient of a squared is 6, not 1, I'm going to use the method of expanding the middle term to factorize 6a squared plus 5a plus 1. What that means is I have 6, that's the coefficient of a, times 1, that will give me +6. Then I need factors of 6, that will give me 5a in the middle. So that's going to be m minus n. I still have my 6a squared. So that will be 3 and 2, because 3 times 2 will give me 6. 3 plus 2 will give me 5 in the middle. So I have that as plus 3a plus 2a plus 1, close bracket. And then I'm going to use the grouping method by grouping in pairs. So I have m minus n, and then I have in bracket the first common term to 6a squared plus 3a will be 3a. So I'm going to use my square bracket. So if I factor out 3a, I'm left with 2a plus 1. And in the second group, I'm going to factor out +1. That's 2a plus 1, close bracket, square bracket. That will give us, I still have my m minus n outside the big bracket. Then inside, I can see there's a common term, that's 2a plus 1. So therefore, I'm going to factor out my common term, which is 2a plus 1, and then I'm left with 3a plus 1. So in order to rewrite this, I have that as m minus n, 2a plus 1, and 3a plus 1. I've been able to factorize fully. I move to the next term, or the next question, that's 3.4, and that says 2x squared, or x cubed, plus x squared minus 6x minus 3. This looks like another grouping. How do I identify factorization by grouping? I have 4 terms, and then I can group in pairs as shown. So I'm going to look for a common term. On my left hand side, I think the common term is x squared. So I'm going to factor out x squared. I'm left with 2x plus 1. And then on my right hand side, the common factor will be minus 3. I'm left with 2x plus 1. I've been able to factorize such that extracting my common factor, then I'm left with 2 common terms on both sides of the expression. So if I take out the common term, which is 2x plus 1, I'm left with x squared minus 3. Then I do a double check to see if I can factorize further. No, so that would be my answer. For question 3.5, I have 3 to the power of n plus 3 to the power of n plus 2. I'm going to start by expanding the term on the right using the laws of exponents that state that if I have x to the power of a plus b is the same as x to the power of a times x to the power of b, because if they have the same base, then you add the exponent. So therefore, this will be 3 to the power of n plus 3 to the power of n times, my dot is multiplication, 3 to the power of 2. So you can clearly see there's a common term or a common factor to each of the terms, which is 3 to the power of n. So if I factor out 3 to the power of n, I'm left with 1 plus 3 squared. That's equal to 3 to the power of n in bracket 1 plus 3 squared is 9. So therefore, my final answer will be 9 plus 1 is 10. So I have 10 times 3 to the power of n. The next example, for 3.6, I have 6 times 5 to the power of 2x plus 5 to the power of x minus 12. In order to solve this question, I'm going to be using what I call the K method to simplify my factorization. So if I rewrite what I have, that will be 6 times 5 to the power of x all squared, laws of exponent. If I expand that, that's 5 to the power of 2x. I have plus 5 to the power of x minus 12. So using the K method, I'm going to say let k equals 5 to the power of x. So every occurrence of 5 to the power of x, I replace it with k. So that will give me 6k squared plus k minus 12. This makes it easy for me to factorize. How do I factorize this? I'm going to use the previous method because the coefficient of k squared is not 1. So if I multiply 6 by negative 12, that's going to give me negative 72. So I need the factors of negative 72 that if I add together will give me a k, that's 1k in the middle. If I multiply, it will give me negative 72. So the method I'm using for factorizing is expanding the middle term, and the factors are 9 and 8. So I have 6k squared plus 9k because I have plus 1, then minus 8k minus 12. So if you check, I've been able to expand the middle term using the factors of 6 times 12, which is negative 72. Then I can group or use factorization by grouping as shown. On my left hand side, what is common? That's 3k. I'm left with 2k plus 3. And on my right hand side, if I factor out negative 4, then I'm left with 2k plus 3. Now I've been able to have the same factor attached to my two terms. If I factor that out, that's 2k plus 3. I'm left with 3k minus 4. Note that that is not my answer because I swapped k and I say that k is to be equal to 5 to the power of x. So therefore, I'm going to solve each one or change my k. So if I change my k, that would be equal to, in bracket, 2 times 5 to the power of x plus 3. I'm only replacing my k. Then I have 3 times 5 to the power of x minus 4. So I've been able to factorize my expression. The last but not the least question, I have question 3.7, which states that x to the power of 1 over 2 minus 5x to the power of 1 over 4 plus 6. That's a direct factorization. I have my 2 bracket. Then I need factors of x 1 over 2. That's x 1 over 4. Then I need factors of 6. That will give me negative 5. That's minus 3 minus 2. And note that if I multiply negative 3 and negative 2, that will give me positive 6. Thanks for watching. Bye.